Alright, so hello everyone. In this video, what I want to do is I want to do a very quick problem regarding graphs or transformations of absolute value functions, right? So this is a pretty interesting problem. We want to describe, or rather figure out the graph, or kind of graph the function given the transformation from f of x to k of x. So basically, it tells us, given the function f of x, it tells us that it went over a series of transformations. That just means that it transformed and it moved in the Cartesian plane. It either, it underwent a specific kind of transformation, basically. And it wants us, and basically we know that the function that is transformed, which is k of x, it tells us how it transformed. So from, given f of x. So that's basically what that's saying. It just means that, k of x was a transformation of f of x with this particular equation here, right? So it says determine the function defined by k of x, then graph the function, right? So basically, we know that this, so first of all, we want to, and I'm actually going to show you guys exactly how to find this function here, because this is the function that they give us. Usually with absolute value, if you haven't seen my videos about absolute value, you can always check those out. But I'm going to show you guys exactly how to determine the graph of this function here for absolute value. So here, obviously, when we have an absolute value, whether it is like this or like this peak point and this minimum point are always defined by h comma k. And there is an equation, a specific equation called Vertex form, or absolute value, or Vertex form of absolute value, that says that f of x can be defined by a times the absolute value of x minus h plus k, right? And a is usually your slope, right? Now this, as you can see, our slope, we go up one and we go to the right one, right? So our slope can be defined as the change in y over the change in x. And we know that the change in y, the change in y is this one, right? It is 1, and the change in x is 1, right? So that's just, the slope is 1. That is what a is going to equal to. So here, f of x is going to be 1, and we're going to put like an absolute value symbol like this, and it's going to be x, and notice that your hk, so the vertex in an absolute value function is right here. This is hk, right? So if I color code this, obviously, I can say that this is h, and then we have plus, let me rewrite that really quick, h, and then we have plus k, right? So we know that that can be defined here, h comma k, right? So here, the vertex is 1 comma 1. We know that the vertex is hk. So what does that tell us? The vertex is defined by hk, and we have a point. We know that the vertex in this absolute value is 1, 1, because that's literally the middle of this absolute value, of this absolute value sketch or graph, right? We can say that the vertex we know is 1, 1. Now, what that tells us is, that this actually means that h equals 1 and k equals 1, right? And so from this, we can go ahead and form our absolute value equation. Now, notice that I said that the slope is 1. That's a. The slope is a, okay? The slope is 1. So that means that a equals 1. Right? So, we know that we can say 1 times the absolute value, and then we have x minus h. We said that h was 1, and k was 1, right? So, so that would be the equation of this graph here. Now they're telling us that k of x is defined by that transformation there. So really, what this means is, so k of x equals, it's going to be defined by -2 times f of x minus 3 plus 2, right? Let me actually, let me color code. So let me rewrite f of x, but I'm going to rewrite it in a different color. F of x, we said, was the absolute value of x minus 1 plus 1, right? And it's saying that k of x is -2 times f of, and it's saying x minus 3 plus 2. So what is f of x minus 3, first of all? We know that f of x minus 3 is going to be, so k of x, he said, so k of x we know is -2 times, so it's x minus 1 minus 3, right? So basically, we want to find f of x minus 3. That means that if we have f of x equals the absolute value of x minus 1 plus 1, we're going to find f of x minus 3 by saying that this basically is going to be plugged in for x, right? So it's going to be x minus 3 minus 1 plus 1, right? So then we have f of x minus 3 is equal to the absolute value of x minus 3 minus 1 plus 1. Remember that the absolute value, there's a reason why it is enclosed. You're not going to add these two because this is inside the absolute value. It is not. You're not gonna combine these two because you can't do that. You're gonna say x minus 3 minus, so it's gonna be x minus 4 really, because -3 minus 1 is -4, like that, and then plus 1. Now it also tells us that it has a translation 2 units up. So basically, you're going to add that 2 here because it is outside the absolute value symbol, right? So you have the absolute value of x minus 4 plus 3. That's because here, when it's saying plus 2, that's plus something on the outside. So that means we're going to add, and we already had this 1 here, so we're going to add 2 to that, and we get x minus 4 plus 3. Notice that there's a negative 2 here as well. That means that that means that it's going to be multiplied. The whole function is going to be multiplied, but only only on the like, it's only going to be multiplied to the absolute value. You're not going to literally multiply it. It just tells you, like, it's going to be on the very front of your absolute value. If I say, for example, f of x equals absolute value of x, then that means that 2 times f of x is just equal to 2 times absolute value of x. That's because f of x is this part. Okay? That's what that is saying. So that means that we're going to multiply negative 2 to f of x minus 3, right? So we have, and this should be, so this is f of x minus 3 plus 2. So then once we multiply negative 2, we have negative 2 times absolute value of x minus 4 plus 3, right? And now we have to graph it. So if I just, give me 1 second. So basically we have to graph this function here. So to graph this function, you first want to determine your vertex. Again, x minus h plus k. H equals 4. K equals 3. Right? So the vertex is at 4, 3. And it's telling us that the slope is negative 2, so you're going to go, that means that on the right side of your absolute value graph, which is this here, it's going to have a slope of negative 2. So you're going to go down 2, 1, 2, to the right 1. And then down, down 2 to the right 1, like that. Okay, so once you do that, you draw a straight line as best as you can, and then you'd reflect over, there's a line called the axis of symmetry. Or you can evaluate if you don't know how to do this, but what that means is you do a reflection. So you do over the axis of symmetry. The axis of symmetry is x equals h. So it's obviously x equals 4 in this situation, right? So we do, it's literally reflecting over a line. 1, 1, 1, 2, 1, 2, etc., right? So then you just go ahead and do this here, right? And so this would be the graph of your absolute value equation given the transformation that they gave us in this problem, where the vertex is at 4, 3, and it is pointing downwards, and the slope is obviously, the slope is basically negative 2, and then to the right 1. So basically the slope A is negative 2 over 1, which is negative 2. The only reason why I define it by A is because of A times absolute value of x minus h plus k, where A is the slope. So that is how you graph this specific function, and that is the transformation that is given by this equation here. So with that being said, guys, I hope this helps. If you have any questions, please let me know. Please like, comment, and or subscribe, and I will see you guys in the next video. Bye, guys.